Hello everyone, in this tutorial we are going to provide a solution to this interesting question related to quadratic equation. The question reads, find the value of r such that one of the roots of the quadratic equation r plus 5x squared plus 3r plus 6x plus 2r equal to 0 is twice the other. It means that one of the roots of this quadratic equation is twice the other, and we don't know the roots, so we can declare them with a and 2a. So let the roots. Next, I would like to divide every single term of this quadratic equation by its leading coefficient. And the leading coefficient is what? R plus 5. So if you take the whole of this and divide it by r plus 5, that will be left with only x squared. Plus, we have 3r plus 6 divided by the leading coefficient, which is r plus 5. We still have x plus 2r divided by the leading coefficient r plus 5 equal to 0 divided by the leading coefficient, which is going to be 0. Next, I would like to form a quadratic equation with these two roots. Remember, to form a quadratic equation with given roots, you can take x squared, then you subtract, then you add those two roots together. If you take this, you add it to this, that will give us 3a's, right? So this is 3a. Then don't forget to attach x. Then plus, then you take the product, meaning you should multiply the two roots together. A times 2a will give us 2a squared. Everything equal to 0. This is a quadratic equation that has the roots a and 2a. Now, since these two equations are related, we can compare their coefficients. We don't have problem with this one because you can see they're all 1, 1. Let's move to the coefficient of x, which is the middle term. You can see that negative 3a is the coefficient of this x, but the whole of this expression is the coefficient of x to the other equation. So they are equal. 3r plus 6 divided by r plus 5. All right? Then the constant, you see the constant here is 2a squared, 2a squared, but the constant from the other equation is 2r divided by r plus 5. All right, now we have two equations. Let me come back to the first equation and make a the subject by dividing both sides by negative 3. So we have a equal to, if you divide the whole of this by negative 3, this negative 3 will only going to divide the numerator. So 3r divided by negative 3 will give us what? Negative r, because 3 will cancel 3. 6 divided by negative 3 will give us negative 2 divided by r plus 5. So this is what we have as a from this first equation. Now let us take it and plug it into the second equation. Wherever we have a, that will be replaced with this expression. So from that equation, we have 2 multiplied by a, but a is the whole of this, right? Minus r minus 2 divided by r plus 5, everything squared because this a has squared. And this is equal to 2r divided by r plus 5. So this is where we're going to solve for r. First of all, let us divide both sides by 2. This 2 and this 2 will cancel by dividing both sides by 2. And I can see that we have a relationship between the denominators, so I will not expand the denominator, rather only expand the numerator. So this will be negative r negative 2 whole squared. I'm going to share the exponents. R plus 5 also squared. This is equal to r divided by r plus 5. We are moving. Now we can expand this confidently, but first of all, let me multiply both sides by this denominator just to clear the fractions. So if you multiply this denominator by the whole of this, it will go, leaving only negative r minus 2 whole squared equal to, if you multiply this by this, you see the denominator has an exponent of 1, so it will cancel one of the exponent here, right? So this becomes only r times r plus 5. So now let us expand both sides. Negative r squared will give us r squared. Then 2 times this times this. Let us multiply them first before we multiply by 2. This time this will give us positive 2r times 2. That will give us positive 4r. Then the second term squared, that will give us 4. This is equal to r times r is r squared. 5 times r is 5r. From left to right, we have this in common. So what do we do next? We collect the like terms. So you can see that 5r is the same thing as 4r plus 4, right? Then if you take this one to the left, it becomes what? 5r minus 4r equal to 4. And 5r minus 4r is a single r. This is equal to 4, which means that the value of r which we are looking for is equal to 4. But to confirm whether the statement is true, remember, it stated that the roots, one is twice the other, right? So let me take the whole of this equation and substitute the value of r. So if r is 4, you can see that this will give us 9, 9x squared. 3 times 4 is 12, plus 6 is 18, 18x. Then plus 2 times 4 is 8. This is equal to 0. So now let us solve this equation and see whether the statement is true. First of all, take the leading coefficient and multiply by the constant. That will give us 72, right? Then think of two numbers you can multiply together to get 72. But the moment you add those two numbers together, you get what? 18. And the numbers are 12 and 6. So we have x plus 12 divided by 9 multiplied by x plus 6 divided by 9. This 9 is the leading coefficient. So we're going to set each to be equal to 0 by taking the constants to the right hand side, but we have to write them to the simplest form. X is equal to negative what? I think 3 can divide this how many times? 4 times. 3 can divide this 3 times. Then the other one equal to negative 3 can divide 6 2 times, and 3 can divide 9 3 times. So definitely you can see that this is twice this, because the moment you multiply this by 2, that will give you this. Therefore, the roots of this quadratic equation are in such a way that one is twice the other. Thank you for watching. Do share to your and colleagues, and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.